It's time to start making some connections between the new vocabulary we have looked at this week, along with some of the ideas from our previous unit on right triangle trigonometry. For today's lesson, it'll be important to define what is known as a reference angle. A reference angle refers to the positive acute angle that an angle in standard position forms with the x-axis. So you have kind of generic examples of what a reference angle is here, what they look like in each quadrant. But I'm going to take an example, the angle pi over 8. So if we take a look at the angle pi over 8, it's roughly here, and we want all of the reference angles between 0 and 2 pi, all of the angles between 0 and 2 pi that have a reference angle of pi over 8. Essentially, we're just looking for all of the angles that are pi over 8 of a rotation away from the x-axis. So in the second quadrant, that angle is going to look like this. So this angle here is the angle 7 pi over 8. Now, how did I figure that out? Okay, well, I know that here we've got pi, right? And if the reference angle is pi over 8, all I did is I took pi and I backed it up by pi over 8. Right? So in the second quadrant, the angle 7 pi over 8 has a reference angle of pi over 8 because this angle is pi over 8 units away from the x-axis. All right, if I'm looking in the third quadrant, okay, this angle is pi over 8 units away from the x-axis, but this time it's pi over 8 beyond pi, and that would be the angle 9 pi over 8. All right, so far we have an angle in the second quadrant, 7 pi over 8. We have an angle in the third quadrant, 9 pi over 8. And then we have one more angle with a reference angle of pi over 8. That angle would be in the fourth quadrant. Right, so that angle is almost a full rotation. It's pi over 8 less than a full rotation, and remembering that a full rotation is 2 pi. Pi over 8 less than a full rotation would be 15 pi over 8, right? Because 2 pi is 16 pi over 8, so 1/8 less than that is 15 pi over 8. So these three angles all have a reference angle of pi over 8. Today we're going to use the idea of reference triangles, which are simply the right triangles that are formed by the reference angles, in order to solve some problems involving the 6 trig functions. All right, so here's our first example. We're going to be looking at an angle whose terminal side goes through the point -12, 5. All right, so let's draw what that angle looks like. Right, this is an angle in standard position that goes through this point. So really, this is the angle that we're looking at. But as I mentioned, we're going to be using what we call reference triangles to be able to evaluate the 6 trig functions of this angle here. Okay, and I chose this angle to start because, as you'll notice, this is an angle in the second quadrant. And hopefully you did the warm-up activity, and you learned that angles in the second quadrant have a positive sine value, right? So second quadrant Q2 angles. Hopefully you learned in your warm-up that they have a positive sine value, and they have negative cosine values and negative tangent values. And we're going to kind of discover why today. Okay, so I mentioned we're going to use a reference triangle to evaluate all of these functions. And a reference triangle is simply a right triangle that has a reference angle. We'll call it theta prime, okay, because it's not the same as the angle theta, but you should notice that it is the supplement to the angle theta. And we're going to start to learn about some relationships between the sines, cosines, tangents, cosecant, secant, and cotangent of supplementary angles. They do have relationships. Okay, so this theta prime, this green angle here, is the supplement to the big angle theta. Okay, so really when we're doing our evaluation, we'll be evaluating the trig functions of this big angle, but we're going to use what we know about right triangle trig and this reference triangle to do that evaluation. All right, so we know that this leg of this triangle is 5. We also know that this leg of the triangle is 12. However, notice that we're going in the negative direction, right? So this 12 also has a direction to it, right? So we're going to call it negative 12, okay? Because we're just to indicate to us that we're going in that negative direction, that leftward direction, or to indicate to us that we are in the second quadrant, right? Second quadrant, x is negative, right? Second quadrant. All right, so the follow-up question says, if the point negative 12, 5 were on a circle, what would the radius of the circle be? So if you can kind of envision that this big circle here, right, with its center at the origin, the radius of this circle is the same as the hypotenuse of the right triangle. Right? And the hypotenuse of this right triangle, if you remember your triples, we have a 5, 12, 13 triple. If you don't remember your triples, you can just use the Pythagorean theorem. 5 squared plus 12 squared is 169. Square root of 169 is 13. So this is our reference triangle here. This green triangle is our reference triangle. And again, typically when we were using SOHCAHTOA, all of our trig values, sine, cosine, tangent, cosecant, secant, cotangent, they were positive numbers because we were talking about side lengths of a triangle. We're going to use what we know about SOHCAHTOA to evaluate these, but also make the adjustment for considering what quadrant our angle is in. Okay, so the sine of angle theta, which is big angle theta, we can calculate using the reference angle theta prime, and again, making any adjustments for the quadrant that we're in. So the sine is still opposite over hypotenuse as it always was, and in this case they are both positive, because in the second quadrant, the opposite side is essentially our y value, and that's a positive number. Our cosine is going in the negative direction, right? Adjacent over hypotenuse. So we're going to make that adjustment for being in the second quadrant, and we're going to call it negative 12/13. And our tangent, opposite over adjacent, again, because our adjacent side is going in the negative direction, we're in a quadrant 2 position, we're going to call it negative 5/12. And hopefully you remember that cosecant, secant, and cotangent are just the reciprocals of these functions over here, right? So cosecant is really just the reciprocal of sine. So I could just flip to get cosecant. Secant is just the reciprocal of cosine, so I could just flip cosine to get secant, and cotangent is the reciprocal of tangent, so I can just flip tangent to get cotangent. So again, notice these guys are both negative because we're in quadrant 2, right? We're in quadrant 2, that x value is negative, and because that x value, or the adjacent side of the triangle, comes into play when we're talking about cosine and tangent, the overall function is also going to be negative. Notice that I'm not asking you for what is the angle, right? I'm just asking you for what are the exact values of the trig functions of the angle. I don't care what angle this is. I don't care what the actual measure of it is. You could use your calculator to find out if you want to, but I'm not asking for that. I'm just asking for what are the values of the functions. All right, let's take another example. This example is the terminal side of an angle goes through the point -1, -3. Right, so this is an angle in the third quadrant. Now I didn't have you investigate very far, very much into third quadrant angles. I did have you do some calculations to kind of figure out the signs of those values, and maybe you could figure out if you're kind of looking and thinking ahead to what our reference triangle is going to look like. You're going to notice that we're going to have both of our sides, both of the legs of our right triangle, of our reference triangle, are going to be going in the negative direction, right? Because of the coordinates that we're looking at here. So I always write, just to remind myself, okay, even though I don't think of the side length of this triangle as being negative, I do think of the fact that it's going in the negative direction, and the same thing with this one. Okay, the side length's not negative. The side length is 3, but it's going in the negative direction. So I'm always going to indicate that negative there. All right, and again, if we think about this as being the radius of a circle centered at the origin, the radius simply becomes our hypotenuse of our triangle. And the length of the hypotenuse of this triangle is the square root of 10. Okay, you'll notice that the radius or the hypotenuse is always going to be a positive number, even though it's pointing down in this direction, because if we think about it, right, if we take -3 squared and then we square -1, both of these are going to end up being positive numbers. So our hypotenuse, or the radius of, if we're going to start thinking about this less as a hypotenuse and more as a radius of a circle, this is always going to be a positive number. Okay. So again, the angle that we're going to be calculating trig ratios for is right here. It's this angle theta. It's this one that's, been rotated almost 3/4 of the way around our circle. But we will use the reference angle in here, call it theta prime again. We'll use that reference angle in there to calculate all of the ratios, again, making the adjustment for the fact that we're in the third quadrant. Okay, so the sine of an angle in the third quadrant, right? Sine is opposite over hypotenuse. The opposite side, we're going to call it -3 to accommodate for the direction, and the hypotenuse is the square root of 10. If we want to write that in simplest radical form, this is just -3 root 10 over 10. It is always best to write them in simplest radical form. Okay, and since we know cosecant is just the reciprocal of sine, we can just flip this right over and write it as -10 over 3. If you like to think of cosecant as hypotenuse over opposite, then go for it. All right, we'll also now look at the cosine. Cosine is adjacent over hypotenuse. So this is -1 over radical 10, which I can simplify to be -root 10 over 10. And then secant, we're just going to flip it right on over, and that's just going to be -root 10 over 1, which is just -root 10. So notice we're in quadrant 3. Sine and cosine are both negative. Let's see what happens with tangent. Tangent is opposite over adjacent. So -3 over -1, that's just going to be a +3. And then cotangent is the reciprocal of that, is 1/3. So tangent is positive in the third quadrant. All right, finally, let's see what happens in the fourth quadrant, and then we'll make some conclusions. All right, so the terminal side of an angle lies along the line 5x plus 2y equals 0. For x less than 0, find the exact value. So this is similar to that preview problem we did the other day. You're going to actually have to draw the angle. 2y equals -5x. So y equals -5/2 x, and I'm only looking at this line when x is less than or equal to 0. Oh, this is not going to be a fourth quadrant angle. It's going to be a second quadrant angle. Let's actually change it so that it's greater than. Okay, so let's change that so that it's greater than, so that we can look at what it looks like in the fourth quadrant. So we're going to make that greater than or equal to 0. So y equals -5/2 x, -5/2 x. It's this line here. It would be this line if I kept going, right? But I want to look at basically this angle, right? Almost, not quite a full rotation of an angle. So I'm looking at this angle. So again, I changed the constraint here because I wanted to look at a fourth quadrant angle. We already looked at second and third quadrant angles. So I want to look at a fourth quadrant angle and see what happens with these ratios. Okay, so we're looking at the line y equals -5/2 x when x is greater than or equal to 0. So this is a fourth quadrant angle. My reference triangle, hopefully by now you can see my reference triangle's right here. So I'm going to consider the angle theta prime when I'm doing these calculations, but also making the accommodation for the fact that I'm in the fourth quadrant, so I have a positive x value and a negative y value. Okay, if I think of this as a big circle, the hypotenuse of my triangle being the radius of my circle, I could use the Pythagorean theorem to figure out what the radius of my circle is. 5 squared plus 2 squared, that equals 29. So my hypotenuse is the square root of 29. All right, sine of, again, we're looking at the sine of theta. We will use the reference triangle, the reference angle theta prime. We'll use the triangle to find sine, cosine, tangent, cosecant, secant, cotangent, and make the adjustment to make sure that we're looking at theta is just coming in the fact that we're in the fourth quadrant and we have a negative y value. So sine of theta is going to be opposite over hypotenuse. That's negative 5 over root 29. If I rationalize, negative 5 root 29 over 29. And then the cosecant is just the reciprocal of that, root 29 over 5. Cosine is adjacent over hypotenuse, 2 over root 29, which becomes 2 root 29 over 29 if I rationalize. And then the secant is root 29 over 2. And then finally tangent, opposite over adjacent, negative 5 over 2. And for cotangent, it's the reciprocal, negative 2/5. So now let's notice, we have a positive cosine in the fourth quadrant and negative sine and tangent. Okay, so again, cosine is positive because cosine is dealing with the adjacent side, which is also x, right? It happens to be x, and the hypotenuse, which is the radius of our circle, if we think of it as a circle, right? Both of those are positive numbers. Sine and tangent both involve the use of the opposite side, so they're both going to have to be negative because we have a negative y value. Let's see if we can draw some conclusions. Okay, if we're on a circle with radius r, again, irrelevant what quadrant we're in, right? I can take this triangle, this reference triangle, and draw it in any one of my quadrants. Obviously here I would have the point, this would also be the point xy, but it would be a negative x, y, etc. All right, I can go all the way around if I want and draw all of the triangles that have this same angle, theta. The sine of theta is going to be y over x. I'm sorry, not y over x, y over r, right? Opposite over hypotenuse. But now we're on a circle, so the opposite side is the y value of whatever this point is, and the hypotenuse is the radius of whatever the circle is. Therefore, cosecant is just going to be r over y. Cosine is going to be x over r, right? Adjacent over hypotenuse. Secant will be r over x. Tangent, we usually think of as opposite over adjacent, while on my circle, it's just y over x, and cotangent will be x over y. And now the values of the coordinates, depending on what quadrant I'm in, are going to affect the values of these trig ratios. So for example, if I'm in the second quadrant, I know I have a negative x value, so any of these trig ratios that involve x are going to be negative in the second quadrant, right? So notice that the only thing that doesn't involve x are sine and cosecant. So sine is positive. Sine is positive in the second quadrant. Okay, the rest are, it's negative cosine and tangent. And then obviously the function that goes along with it, the reciprocal function, sine and cosecant, and then cosine and secant, and tangent and cotangent. But positive sine, this is what we're going to want to kind of keep in mind, positive sine. Down here, right, if I have a point, I have a negative x and a negative y. Anything that involves only x or only y is going to be negative. Notice tangent involves both y and x, and when I divide a negative by a negative, I get a positive. So the only thing that's positive down here is tangent. So we have a positive tangent, and we have a negative sine and cosine down here. And finally, in the fourth quadrant, right, we're looking at a point here that's positive x, negative y. So anything that involves y is going to be negative. The functions that involve y are sine and cosecant and tangent and cotangent. So cosine does not involve y. That means cosine must be positive here. And then we have a negative sine and tangent. What do you think about the first quadrant? Right, we've got positive, positive here. So all values, all functions rather, are going to be positive here. All right, so you might have heard, I don't know, in your studies somewhere along the way, that, let me use a different color, all students take calculus. Whether that's true or not, this does help us remember which functions are positive in the different quadrants. Right, so all the trigonometric functions are going to be positive in the first quadrant. Sine only, starts with an S, or sine and cosecant really, but sine and cosecant are going to be positive in the second quadrant. Tangent and cotangent, with the T, will be positive in the third quadrant, and cosine and secant will be positive in the fourth quadrant.